Chapter 1.1.3 The Kubernetes API. The API server is the core of Kubernetes control plane, allowing communication between different parts of the cluster, end users, and external components through an HTTP API. This API enables querying and manipulation of Kubernetes API objects like pods, namespaces, and config maps. Operations can be done through command line tools like kubectl and kubeadm, or directly through REST calls. Kubernetes provides client libraries for developing applications using the API. Each cluster publishes API specifications using the Discovery API and the Kubernetes OpenAPI document. The Discovery API gives information about API names, resources, versions, and operations, while the OpenAPI document provides full schemas for all Kubernetes API endpoints in OpenAPI v2.0 and 3.0, with v3.0 being the preferred method due to its comprehensive and accurate view of the API. It includes all available API paths, resources, operations, and extensibility components supported by the cluster. Kubernetes offers support for both aggregated and unaggregated discovery APIs. Aggregated discovery is considered stable in Kubernetes v1.32, with two endpoints, SHAPI and SHAPIs, providing access to all supported resources in a cluster. This reduces the number of requests needed to fetch discovery data. By specifying the accept header with the resource type, users can access the aggregated discovery resource. The discovery document for built-in resources can be found in the Kubernetes GitHub repository for reference if a cluster is not available for querying. On the other hand, unaggregated discovery is published in levels, with root endpoints providing information for downstream documents. Additional requests are required to obtain the discovery document for each group version. These endpoints, e.g. APIs rback.authorization.io v1 alpha 1, are used by kubectl to retrieve the list of resources supported by a cluster. OpenAPI interface definition. The OpenAPI documentation provides details about the specifications available in Kubernetes, with support for both OpenAPI v2.0 and OpenAPI v3.0. The preferred method is using OpenAPI v3 as it offers a more comprehensive representation of Kubernetes resources. OpenAPI v2 has limitations such as dropping certain fields from the published specifications. Kubernetes serves an aggregated OpenAPI v2 spec via the OpenAP/v2 endpoint. On the other hand, Kubernetes v1.27 supports publishing API descriptions in OpenAPI v3 via the /OpenAP v3 endpoint, which only returns JSON. The API server sets proper caching headers for client-side caching and redirects to the newest URL if an obsolete one is used. Kubernetes 1.31 publishes both OpenAPI v2.0 and v3.0, with no current plans to support 3.1. Additionally, Kubernetes implements a protobuf-based serialization format for intra-cluster communication. More information on this format can be found in the Kubernetes protobuf serialization design proposal and the interface definition language (IDL) files in the Go packages defining the API objects. Persistence. Kubernetes stores object state in etcd by serializing them and writing them. API groups and versioning. Kubernetes uses multiple API versions to make it easier to eliminate fields or restructure resource representations. Versioning is done at the API level to ensure a clear, consistent view of system resources and behavior while allowing control of access to experimental APIs. API groups can be enabled or disabled to evolve and extend the API, with resources distinguished by API group, type, namespace, and name. The API server handles conversion between versions transparently, serving the same data through multiple API versions. Kubernetes aims to continuously change and grow the API without breaking compatibility with existing clients, adding new resources and fields regularly. API deprecation policies are followed when eliminating resources or fields. Compatibility is maintained for official APIs once they reach GA, with data persisted via beta APIs also convertible to GA versions. Transitioning to subsequent beta or stable API versions is necessary once a beta API graduates to stable. While Kubernetes strives to maintain compatibility for alpha APIs, in some cases this may not be possible. It is important to check the release notes when upgrading a cluster using alpha APIs, as they may change in incompatible ways. For more information on API version definitions, refer to the API versions reference. The Kubernetes API can be extended in two ways, using custom resources to define how the API server provides a chosen resource API, or implementing an aggregation layer. Custom resources allow for declarative definitions, while the aggregation layer offers another method for extending the Kubernetes API.